Welcome to the second year English students. The course Computer Applications. The lecture starts from page 223 up to page 255. The course is presented by Dr. Karam Fai. Chapter 6. Applications of Uncertainty Decision. The following criteria of decision making under uncertainty have been discussed. The optimism or max or min criteria, the pessimism, max-min, min-max criteria, equal probabilities Laplace criteria, coefficient of optimism or heroics criterion, regret or savage criterion. Decision making is certainly the most important task of a manager, and it is often a very difficult one. So the software is used to assist the decision maker in making a decision. The Microsoft Excel offers a decision-making procedures for solving complex problems step by step. In decision-making under uncertainty, the decision maker has no knowledge regarding which state of nature is most likely to happen. The most common way of solving problems with uncertainty is to use simple rules called decision criteria to recommend a solution. There are many different criteria that can be applied to get better decision. The first criteria is called optimism or max or min or aggressive criterion. The decision maker achieves the largest possible profit by using the max function or the lowest possible cost by using the min function. This criteria is summarized as follows. Number A, locate the maximum or minimum payoff values corresponding to each decision alternatives. The maximum in case of profit or gain, the minimum in case of losses or cost. Then select a decision alternative with best payoff value, the maximum in case of profit, and the minimum in case of cost. This criteria can be explained by using the application 1. An investor is given the following investment alternatives and the percentage rates of return during 1 year, as given in the following table. The alternatives: bonds, stocks, and deposits with different state of natures, high, medium, no change, and low. Using Excel, find the action to be taken among 3 possible courses of actions with the given rates of return. Solution: make a copy of the above table into Excel sheet as given in figure 1. Then apply the criteria max to achieve the largest possible profit as follows. First of all, locate the maximum payoff values corresponding to each decision alternative by writing the following function in cell H4. Max from the cell D4 in cell optimism, cell H4. Write the max equal sign max from D4 up to G4. Start from D4 up to G4. Then click and drag the autofill until to reach to H6. You will get the resultant value 12%, 15%, and 7%. Then select the maximum outcome, which is corresponded to 15%, by writing max from H4 up to H6. You will find the best alternatives is the stocks. Click formula and then show formula to get the formula instead of the executions, as you see in figure 3. Then we have to write in H7, as we said before, to find the best investment, writing the max from H4 up to H7. As you see, you will get 15%. The solutions or overall solutions will be obtained as in figure 5. You will see the maximum and the maximum from H4 up to H, then the decision is the alternative. If the decision is repeated, the average return in the long run will be equal to 15% in case of stocks. If decision is made only once, the return could be any of the 4 values: 15%, 9%, 5%, and the negative 2%. The second criteria is called pessimism or conservative. In other words, it's called max-min or min-max criterion. This method is called also walled decision criterion. The pessimism method is summarized as follows: locate the minimum value in case of profit, or maximum in case of cost, corresponding to each decision alternative. Then select a decision alternative with the best payoff value, maximum for profit and the minimum for loss or cost. The following application to explain this criterion. A restaurateur is going to set up a cream tea stall at local gala. In the morning of the gala, he visits the wholesale market and has to decide whether to buy large, medium, or small quantity of strawberries, scones, cream, and other materials. His profit depends on the number of people attending the gala, and this in turn depends on the weather. If his gain matrix in thousands of dollars for different weather condition is given below, given the matrix, payoff matrix alternatives, case of large quantity, medium quantity, small quantity, and stated natures of the weather, when the weather good, average, and poor. Using Excel, find the quantity of material he should buy. Solution: make a copy of the above table into Excel sheet as given in figure 6. Then the payoff matrix represents gains. Therefore, the worst outcome for each alternative is the lowest gain. The lowest gain in each alternative is obtained by applying the following form in G4. In G4, we have to write min from the cell D4 up to cell F4. Then click and drag the autofill until you reach to G6, as you see in figure 8. Then in G7, write the following formula: equal max from G4 up to G6. You will get figure 9. In figure 10, the resultant value of the execution of the functions, you will see that the medium quantity is the best alternative to make a decision. G5. So the decision is the alternative medium quantity. Therefore, if the decision is repeated, the average return in the long run will be equal to 5 in case of medium quantity. If the decision is made once, then the return could be one of the three values, 12, 8, or 5. The overall solution of the problem is given in figure 11. Another criteria is called equal probabilities or Laplace criteria. The Laplace method is summarized as follows. Assign equal probability value to each state of nature by using the formula. The probability of each state of nature is equal to 1 divided by the number of states of nature. Then multiply each element of the payoff matrix by the probability. After that, add alternative rows and put the average in the expected payoff column. The above three methods, A, B, and C, can be replaced by mean or average. Then select the best expected payoff value, maximum in case of profit, and the minimum in case of cost. The following application explains the above criteria. Application 4. A firm has a problem with the following payoff matrix of costs. Apply Laplace criteria using Excel to show the best alternative. We have three states of nature, 1, 2, and 3, and three strategies or alternatives, A, B, and C. Solution. First of all, make a copy of the above table into Excel sheet as given in figure 18. Then apply Laplace criteria as follows. In G4, write the following formula. Equal average from the cell D4 up to cell F4, as you see in figure 19. Equal sign, average from the cell D4 up to G4, then click and drag the autofill until you reach to G6. You will get the resultant value as you see. Then select the minimum value. The min value by writing the function equal min from G4 up to G6. Write in G7. G7 write equal min from G4 up to G6. You will get the best outcome by using the function min, as you see, which is equal to 14, which is the strategy or alternative A. So the decision will be, the overall solutions will be given in figure 23, and the decision will be the alternative A, as you see in figure 20. The final solution of the displaying all the functions in the corresponding cells are given in figure 24. Therefore, if the decision is repeated, the average return in the long run will be equal to 14 in case of strategy A. If the decision is made only once, the return could be any of the three values, 14, 22, or 6. Another criteria is used for decision. This is called coefficient of optimism or Hurwitz's criteria. The decision maker should be neither completely optimistic nor pessimistic. Hurwitz introduced the idea of the coefficient of optimism alpha to measure the decision maker's degree of optimism. This coefficient lies between 0 and 1, where 0 represents a complete pessimistic attitude about the future, and 1 represents a complete optimistic attitude about the future. Therefore, alpha is called the coefficient of optimism, and 1 minus alpha is called the coefficient of pessimism. The Hurwitz coefficient H is summarized as follows. First of all, choose alpha between 0 and 1. Then calculate H, the Hurwitz coefficient, according to the following form. H equal to the coefficient of optimism alpha multiplied by the large outcome plus the coefficient of pessimism 1 minus alpha multiplied by the small outcome. Then pick the alternative or outcome with the largest value in case of profit or the smallest value in case of cost. The following applications explains the above criteria. Application 5. Mechanical engineer ran a plumbing wholesale business based in Europe. 5 years ago, he developed a simple valve mechanism for controlling the flow of water in domestic solar heating systems. The engineer was slightly pessimistic. He had to decide how to market his idea. And in the short term, his options can be summarized as: sell the valve locally, sell nationally through a website, enter a partnership with an existing company, or sell the patent. His returns depend on demand, which he described as high, medium, or low. He developed the matrix of potential annual gains as follows. Given the alternatives: market locally, use website, partnership, sell patent, and the state of nature's high, medium, and low. Then apply a suitable criteria using Excel to show the best alternatives. We have to type the above table into Excel sheet to get figure 25. Then choose the coefficient of optimism alpha equal 0.4 and type it in cell E1 as given in figure 26. The coefficient of optimism alpha equal 0.4, which is constant. It means when we refer to the cell A1, it should be surrounded by dollar signs to keep it fixed when we make a click and drag. Then apply the Hurwitz criteria as follows. Calculate H by writing in cell G4 equal sign E1 surrounded by dollar signs to keep it constant when we click and drag the autofill, multiply by the maximum from cell D4 up to F4 plus the coefficient of pessimism, which is equal to 1 minus the cell E1 multiplied by the minimum value by using the function min of cells D4 up to F4. Then click and drag the autofill until to reach to G7. As you see in figure 28, you will see the resultant value after applying the above functions. Then write down in cell G8, write down the function equal max between cell G4 up to G7 to get the maximum value, which corresponds to value 60. So we have to use the alternative, use website. As you see, so the best value for outcome is the use website. The overall solution of the problem is given in figure 31 and 32. The execution of the equations will be seen in figure 31, and the formulas will be displayed in figure 32. Then the decision will be taken as, if decision is repeated, the average return in the long run will be equal to 60 in case of use of website. If the decision is made only once, the return could be any of the three values. As you see from figure, three values, it could be 180, 110, or negative 20. Another type of decision making is called regret or savage criteria. This criterion is also known as opportunity loss decision or min-max regret decision criterion, because the decision maker regrets for choosing wrong decision alternative, resulting in an opportunity loss of payoff. Thus, the decision maker intends to minimize this regret. This method is summarized as follows. Compute the regret matrix as follows. Find the best payoff corresponding to each state of nature, largest payoff in each column. Then find the regret for every entry in the column, which is the difference between the entry itself and the best entry in the column. Then, for each alternative, identify the worst value by writing or finding the maximum regret. Then choose the alternative with the lowest of these highest regrets. These steps can be explained in the following applications. Application 6. A food products company is contemplating the introduction of revolutionary new product with new packaging at much higher profit or much higher price P1. It may even make a moderate change in the composition of the existing product with a new packaging at a small increase in price P2, or may make a small change in the composition of the existing product backing it with the word new, and a negligible increase in the price B3. The three possible states of nature are high increase in sales, no change in sales, and a decrease in sales. The marketing department of the company worked out the payoffs in terms of yearly net profits for each of the strategies of three alternatives. This process is summarized as follows. Given the following table, the three strategies P1, P2, P3, and the three state of natures, high increase in sales, no change, decrease in sales, as given. Apply regret criteria using Excel to show the best alternative. The solution. Make a copy from the above table into Excel sheet to get figure 33. As you see, figure 33. Then compute the regret matrix as follows. The largest payoff in each column by writing the following formula. We have to find the largest payoff for each column. So, for each column, we have to find the maximum value by writing the function max of D4 up to D6 in the cell D7, as you see in figure 34. Then click and drag the autofill until to reach it to F7 to get figure 35. So the largest value in each column are obtained from D7 up to F7. Then find the regret matrix for every entry in the column by writing the following formula in D9. So the regret matrix will be obtained by writing equal APS, which is called, or the abbreviation of the absolute value, by subtracting D4 from the cell D7. ABS is written in to take the absolute value of the resultant value. Then click and drag the autofill until to reach to F11. You will get the regret matrix as given in figure 37. Regret matrix as you see in figure 37. Then for each alternatives P1, P2, and P3, select the maximum regret by writing the following in G9 equal sign max from D9 up to F9 as given in figure 38. Max from D9 up to F9, then click and drag the autofill until to reach it to G11. You will see in figure 39. Then choose the alternative with the lowest of these highest regrets by writing the following formula in G12. Writing G12 min from the cell G9 up to G11 as you see in figure 40. The overall solution of the problem will be given in 41 and figure 42. So the overall solution will be seen in figure 42. Therefore, If decision is repeated, the regret in the long run will be 150,000 in case of much higher price B1. Remember, from the above criteria, we will find if you are working as a consultant and other people judge the quality of your decisions, you might use the savage criteria. If the decision is made for a small company that cannot afford high losses, then Wold may be the best. If there really is nothing to choose between different events, Laplace may be useful. Thank you very much and see you later on.